This question says item 58 refers to the diagram below. So you've got a circle, and it's always good to analyze the diagram before you even go to the question. Before you even read any further, try to analyze the diagram to recall information off your head, you know? So that's a circle, and bear in mind, when there is a line passing through the center from edge to edge that touches the circumference, that line is a diameter. So AC is a diameter. Normally they will use O for the origin. So AC passes through the origin, edge to edge, that's a diameter. Now, if there's another line goes from edge to edge that does not pass through the diameter, it's a chord. Okay? Let's take a look at a diagram that labels a circle. Yeah, so you can just go to Google and look at parts of a circle, and here you have a diagram showing you the parts of a circle. So as you can see, our diameter goes straight through the center, edge to edge. The radius is from the center to the edge. So the radius is half of the diameter. The radius, two radii will make an arc. And you have a minor arc and you have a major arc. A tangent is a straight line that touches the circle outside, right, at one point. So the tangent is outside of the circle. It touches the surface of the circle at one point. You have a chord. A chord is a straight line that is inside of the circle. It goes from edge to edge, but does not pass through the center. Okay, and chords normally make segments. So you have a minor segment that was made by that chord. Okay, and yeah, and you have major segments. The major segment now is the outer portion of that same chord that we have here. You have the minor segment and the major segment. A sector now is an area of the triangle that is made by two radii. Okay, so you have the minor sector and you have the major sector. Okay, made by two radii. So now, coming back to our diagram, make sure that we have this in mind. DA is a chord. DB is another chord. BC is a chord. AC is a diameter. AB is a chord. ABC is a triangle. Now, again, we have to bear in mind circle theorem. We have to have that in mind. So this has to be included in our personal list of formulas or personal list of information, circle theorem. Also, you must have circle theorems. You must have them memorized. Okay? You must, because you cannot go into the exam with the theorems printed out. So you have to have them in your mind. Alternate angles, alternate segment theorem, angle in the center theorem, angles in a semicircle. Anytime you have a diameter, look out for this one. There's a 90 degrees. You have the angles in the same segment. All right. This theorem is made by chords, four chords. Okay. I normally call it the butterfly. Okay. The two angles are the same. Okay. And the alternate angle segment, there's a tangent. Once you have a tangent, be suspicious that you might have to apply the alternate segment theorem because the angle outside is equal to the inside opposite. Okay, the alternate angle inside, they are equal in length. The one that touches the tangent and the one that inside opposite. Okay, so anytime you see a tangent, bear that in mind. Anytime you see these two angles in the same segment, have that butterfly effect, they are equal. You have the cyclic quadrilateral, a four-sided figure inside of a circle. The two opposite angles are supplementary. That means they add up to 180 degrees. The chord, okay, the chord and the radius, okay, depending on make a 90, but bear in mind, you have the chord of a circle, so you have this, but a very popular one is the chord and the tangent makes a 90 degrees, okay, and here you have it happening twice. Okay, so applying this now to our diagram, we can clearly see the butterfly. So ADC, BCA are equal in length. Okay, let me analyze this. Equal in size, sorry, because we're talking about angles. So therefore, we can clearly see ABC is 90 degrees. Okay, because AC is a diameter. So this is already 90 degrees right there. Okay, that comes from the circle theorem. Semicircle, yes? 90 degrees because this is a diameter. Again, we can also see another theorem there. ACB, whatever it is, we don't know yet, and ADA are equal in length. But we also know that the three angles in a triangle adds up to 180 degrees. So we can clearly get what is BCA because we have 35. All of this, you can deduce all of that even without looking at the question yet. So clearly, if we subtract 45 from 90 degrees, we're supposed to get ACB because CBA is already 90 degrees. Three angles in a triangle add up to 180 degrees. So 90 minus 35, that will give us so much. 55? So BCA is 55 degrees. So if BCA is 55 degrees, from the theorem whereby the angles in the same segment, if you want to put it that way, the butterfly effect, ADB is 55 degrees also. Okay. If we don't looking at the question, let's take a look at what the question is asking. In the diagram above, CAB is 45 degrees and AC is the diameter. So the question is asking, what is the angle ADB? ADB. ADB is 55 degrees. The reason why ADB is 55 degrees is because ABC is 90 degrees from the semicircle theorem. Angles in a triangle add up to 180 degrees. So this is 90 between BAC and BCA have to add up to 90 degrees. Subtract 45 from 90, we get 55 degrees. And from the angle in the same semicircle theorem, ADB to that effect is also 55 degrees. So the answer must be A. So these are the two theorems that were applied, angles in the same segment theorem, the butterfly effect, and angles in a semicircle, 90 degrees. These were the two theorems that were applied to figure out that answer.